How's it, Earthlings? I trust all is well. This is the third video in the Grow Room series, and we will be covering genetics. I'm going to try and make this as short as I possibly can, but give as much info as possible. I'll try to keep it under 3 hours. That being said, I'm not training any geneticists or botanists. I'm still a noob when it comes to all of this, but not as newbie as a lot of other people out there. So we'll gloss over the technicalities, but the objective of this video is to show you how to crossbreed the best strain in the game as quickly as possible, whether it be hemp, corn, potatoes or pumpkins. The following tutorial applies to all, and it's a step-by-step tutorial. You don't need to understand genetics to be able to crossbreed the strains you want. You just need to pretty much follow the tutorial. So let's get the show on the road. I'm assuming the following. Number 1, you can double click. 2, you have a farm. 3, you've grown stuff before. If not, watch the 2 previous Grow Room videos. So let's get to it. Plants in Rust have various stages of growth. We have stage 1, or stage 0 technically. Seed, then seedling, then sapling, then crossbreeding, then mature, then fruiting, then ripe, then dead. Now we're going to be concentrating on basically seedling, sapling, crossbreeding. Alright, so now the complicated part, genetics. I'm sure you're aware, all the plants in the game have 6 gene slots that can take specific genes, good and bad. They are as follows: G, increased growth speed; Y, increased yield; H, good for bad environment, that's basically the hardiness of the plant; W is the gene that requires more water, bad gene; and then X is a null gene or a spacer gene, also a bad gene because it doesn't contribute good, and if it doesn't contribute good, it's bad. So what we're going to be trying to do, or going to be doing, is breeding the ultimate gene, or the ultimate plant, which will be 3 Gs, 3 Ys. Quite a few people say 4 Gs, 2 Ys, but from my experience, 3 Gs, 3 Ys, in a good environment, you get the best yield in the shortest amount of time. But it's relative to the environment that you're in. So yeah. So step 1, planting seeds and gardening attire. It's super important that you have frog boots, as well as tactical gardening gloves and sunglasses. They increase your yield by about 25 to 30%. That's always a good thing. Okay, now we're starting with 1,000 seeds. So we're going to plant them in the planter boxes. As you can see, 1 slot away from each other, so no crossbreeding takes place. Now the problem is, if you plant them right next to each other and you crossbreed, obviously the red genes always take priority. They, in inverted commas, weigh more than the green genes. So we place them all neatly like that, and obviously the more genetic, see I fucked up there, anyway, doesn't matter. Okay, the more you plant, the more genes you end up with at the end. And what we're going to be doing is we're going to be harvesting plants only with 2 Gs, 2 reds, or preferably 1 red. And obviously if we get a plant that's all green, then A for away. But mostly we try and get one red only. Okay, so now comes the cloning part. I do fuck up a couple times harvesting instead of cloning, but see, 3 reds, bad idea. So we leave that. Any plants that are in the still in the seedling stage, you can't harvest, but as soon as they get to sapling, you can harvest. So 2 reds, harvest. That's still seedling. Okay, three reds turf that. That's a good one. And basically we just go through all 16 planters, cloning the plants that have got 2 reds or less than 2 reds. And another thing, those reds mustn't be touching each other. That's quite an important rule. Because trying to crossbreed 2 reds that are touching each other is almost impossible. Not impossible, but difficult. So harvest everything, all the good genes. Now as you can see, none of them have crossbred because there's no plants next to them to crossbreed with. So we're keeping the genes as pure as when we first planted them. So I'll fast forward until we've got all our good genes. Okay, so now this is the important part. Sorting out your genes. I just put 3 fridges here. Genes that contain more than 1 red, then genes that contain only 1 red, and then genes that contain no red. So it makes it easier later on when you are writing the stuff down and doing calculations. Alright, now onto gene sorting. What we're going to be doing is putting all the plants with a bad gene into our first inventory column, all the plants with the bad genes in their second slot into the second column, and all the genes of the third bad gene into the third column, and so forth. This isn't necessary, but it makes it easier to visualize how everything works later on when we start writing stuff down. If you find that you don't have enough clones to fill up all 6 columns, then just plant more plants and make more clones. Okay, so now you can see we've sorted them as I said. Bad gene second, bad gene third, bad gene fourth, bad gene fifth, and the bad gene in the 6th slot. Now you can split the genes, or you can split the plants so that you've got makes it easier when you plant it. So out of that you can basically plant 3 lots. So we'll do that. Do the same for the 3rd column. Same for the 4th column. We've got enough there. 5th and 6th, so on. So essentially we can plant 6 or 2 full planter boxes and see what we get out of it. Okay, so I would suggest pausing this after I've done talking so you get an idea of what's going on here. Let's take the first row. Top first column, first row, clone 1. There's an X, there's a G, there's a G, there's a Y, there's a G, there's a Y. Now there's 1, 2, 3 G's, 2 Y's, and an X. There's more G's than there are Y's or X's, which means we'll get a G out of it. And you apply the same for the 2nd row, same for the 3rd row, same for the 4th row, same for the 5th and 6th. And your result will be G, Y, 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 and then a 50-50 YG, and then you'll definitely get an H. But we'll have an all green plant. Now as you can see from the 2nd row, pretty much the same thing. Now what I've done is I've actually trimmed a couple of the genes, or a couple of the clones, because they have genes in it that are either overlapping or not needed. So I've removed clone 4 and clone 5 from the top row, and I've removed clone 2 from the second row, because they don't really add anything, because we're trying to go for G's and Y's. So that's basically the whole gene addition thing, if you want to work it out like that. It's a schlep, but there's an app for that. Alright, so I've neatly arranged our donor genes or clones and our recipient seeds. So the seeds are irrelevant, they can be any seeds or clones. The donors are obviously the ones that are going to be contributing the genes to your recipient. So set it out however you want to make it as neat as possible, and then plant all 4 as we are of your recipient genes or your recipient plants, as I'm doing, and then wait for a later sapling stage. Alright, now that your recipient plants have reached a stage where they will crossbreed before your donors, it's time to plant the donors. So you can plant the donors however you wish. Obviously, one specific donor per planter box, because those genes are the genes that are going to be going into your recipient plants, which are your middle ones. Doesn't matter how you plant them, just as long as you don't plant the same gene in the same box. When the middle plants reach crossbreeding, those are the genes we're looking for. So once all of those are planted, we basically sit back and wait for the middle plants to crossbreed, and we make clones from them. Sit back, chill, and wait for your good genes. Alright, so half an hour later, around about, we have our crossbred clones, all G's. Some of them might vary a bit depending on your donor gene, but they're all green. That's the most important thing. As you can see from the bottom there, we got 9 of the same and 2 others. So essentially good genes all in all, but we want to get rid of that H. Yeah, definitely get rid of the H. Okay, so now we would start the 50-50 method to replace a specific gene, like the H or whichever gene you want to replace with whichever donor gene. But I just realized that I've wasted almost 15 minutes of your time, and 15 minutes you can farm a lot of nodes with that. So as I said before, the best your final crossbreed, you can do all the additions, do it all longhand, or we live in the 21st century. Thanks to Tamura, there is a online app that you can just put in your genes, you add the crop, you choose which priority you want, whether it's yield, growth, hardiness, and you just keep putting in gene strains or gene strings, and eventually it'll spit out something you want. And it's called the Rust Genetics Calculator. And why do it longhand when you could use a calculator? Works like a charm every time. So I would suggest doing that. I'll drop a link in the description at the bottom. But yeah, that pretty much concludes the whole genetics thing. It's not that difficult, it really isn't. The only other thing I would like to cover is backing up your good genes. So take 10, 15, 20 clones, stick them in a box, stick them somewhere where you're not going to use them. There's nothing worse than doing a whole harvest, harvesting all your cloth and realizing, fuck, you've lost all your good genetics and you have to start over again. So put them in a box, put them in a stash, whatever. Just put them away for a rainy day as a seed bank. Lastly, I'd just like to thank Tamura77. I'll put a link in the description for his channel, as well as for the Rush Genetics Calculator, which makes things infinitely easier to do. But yeah, sweet. Hope you guys found the video fairly informative, and good luck with the scrap, and make sure you have your farm close to bandit, because it's a bitch transporting that amount of cloth up and down and up and down, unless you have a car and you're close to the road. But anyway, I digress. Have a good one, boys. Check you on the next video. Almost forgot about the most important thing. What strains we got at the end of it. As you can see on screen, pretty much fast growing hardy, the hours, the amount of cloth, yeah, those are the statistics, and they work every time. So I go with balanced, definitely with balanced. So yeah.